Can you see the screen?
Yes.
Okay. So already we have discussed few rules related to limits. Okay. Last class we were discussing if limit x tends to 0, sin x by x we are having, the result will be, Miraj,
The result will be 2.
2 or 1?
1.
It will be 1. Then just a second. Few more formulas we are having. Yeah. Limit x tends to 0, 1 minus cos x by x, the result will be 0. Okay, learn this formula just like the previous one. Today, however, okay, you just need to know this formula. Okay, today we will be doing few piecewise defined functions. Limit we will be finding. Okay,
Okay. Okay.
so the question is, find limit x tends to 0 f of x and limit x tends to 1 f of x, where f of x is a piecewise defined function. Okay, let me write it. So this is the question. Can you see the question on the screen?
Yes.
Let's continue. This is the question. What we have to find? Limit x tends to 0 f of x. Here the limit will change. Okay. When we are talking about the limit, that time we think about x is approaching 0. Okay. There is a number 0 and x is approaching 0 from the left side. X is approaching 0 from the right side. Is this two values
Yes.
are same or not? Over here we have to think this manner because you can see left side, right side of 0, different functions are given. Can you see?
Yes.
Previously we used to have just one function, that is f of x is equals to 2x, or maybe f of x is equals to 3x, or maybe f of x is equals to 5x by x plus 2. Okay, just only this type of function used to be there, and find the limit when x is approaching 2, or maybe find the limit when x is approaching 5. So directly we used to put the value, right?
Yes.
Okay, so when we are supposed to find the limit when x is approaching 5, the function is not changing. From the left of 5, right of 5, exactly the function is same, 5x by x plus 2. Okay, hence we were just substituting 5 at the place of x. If that was coming as a 0 by 0, then we were just thinking about doing the simplification. Oh yeah, you wanted, have I explained splitting the middle term in the last class?
Yes.
Oh yeah, okay. Let's continue. So here the function is changing. That is, if our x is smaller or equals to 0, see, if here, if our x is smaller or equals to 0, maybe if x is 0, we have to use this function. If x is smaller than 0, that means minus 1, minus 2, or maybe any decimal number, we have to use this function, right?
Yes.
And if our x is bigger than 0, it's not. Most of the time a student, okay, are not that comfortable with this type of function. When the function is piecewise defined just like this, they start getting confused. Please be careful that this is just a simple situation, that when your x is smaller than 0, then use this as a function. When your x is bigger than 0, then use this as a function. It's that simple. Making sense? Getting it, Miraj? Are you getting it? Can you hear me? Can you hear me?
Ma'am, you're lagging.
Okay, it's lagging. Can you hear me? Is it still lagging?
Yes, now I can hear you.
Okay,
No.
okay. So here, Miraj, we need to think. We have to find limit x tends to 0. We will be checking. Limit means towards the left of the 0, towards the right of the 0. We have to check. Okay, that f of x is giving which no, which value. If you are thinking that why we were not doing the same in the previous question, then again I am repeating, in the previous question the function was not getting changed. Okay, that means towards the left of the 0 the function was, if the function was 5x, toward the right of the 0 the function was still 5x. That's why we were not checking that here what will be the value, or maybe here what will be the value. But in this situation we will be checking. Here in the left of the 0 the function is 2x plus 3, and the right of the 0 the function is 3 times x plus 1. Are you getting? The function is getting changed. So we will be finding the limit, left hand limit. Have you
Mm.
heard this terminology, Miraj? Left hand limit, that means 0 minus. That means
Yes,
when we are approaching 0 from the left side.
yes,
Okay, f of x. That time we don't have to
yes,
do anything. This is just the way of writing it. You just need to use the function properly. That towards the left of the 0, the function will be 2x plus 3. Getting it, Miraj?
yes,
Okay, just 2x plus 3. And do we need to put the x value as a just 0? Yeah, just 0 we need to put. Accordingly, we have picked the function. Making sense?
yes.
So the answer is 3. Is it clear?
Okay, the left-hand limit is equal to 3.
Yeah, left hand limit is equals to 3. The left hand limit, how we have found, is that confusing or that is clear?
It's clear.
Now we will be finding the right hand limit. That means when we are approaching 0 from the right direction, when we are approaching 0, that is f of x, then what is the y value?
Yes,
So limit x tends to 0 plus, accordingly we have to choose the function. Okay, towards the right of the 0, the
yes,
function is 3 times x plus 1.
yes,
Here we will substitute x, at the place of x we will substitute 0, and what are we going to get? Just
just 3.
just 3. That means we can see towards the left of the 0 or towards the right of the 0. Okay, the function is approaching the same number, that is 3. Making sense?
Yes, ma'am.
We will write that left hand limit is equals to right hand limit. Therefore, clear? Let's do the next part, where we have to check what will be the limit when the function, when x is approaching 1. Okay, this one also we have to do. If we will check towards the left of the 1 and towards the right of the 1, can you tell me, Miraj, how to approach this part? That x is approaching 1 towards the left and x is approaching 1 towards the right. This two situation we have to find. Yes or no? Because the function is piecewise defined function. Right, Miraj? Can you hear me? Can you hear me?
Yes, I got disconnected.
Oh, yeah. I didn't notice. Can you? So this part, the circled one, also we have to find limit x tends to 1 f of x. Here also we will be talking about towards the left of the one, towards the right of the one, right? Right?
Yes.
Okay, because our function is piecewise defined function. Till now we were not having this type of function. So towards the left of the one, can you tell me which function shall I use? 2x plus 3 or maybe 3 times x plus 1? Which one?
2x plus 3.
Yeah, can you hear me? Is there any connectivity issue, Miraj?
Yes, I have some network issues, so I keep getting disconnected.
No worries. Okay, let's continue. You can hear me, right?
Yes.
See this orange color line. Okay, it is a real line. Okay, I am just making 0 over here. And towards the left of the 0, the function is f of x is 2x plus 3.
Yes.
And towards the right of the 0, the function is f of x is 3 times x plus 1. Now, we are checking the limit at 1, right?
Yes.
And we are trying to check what is happening towards the left of 1, towards the right of 1. And yes, Miraj, when we are thinking towards the left of the 1 and towards the right of the 1, we don't go so far. We just, okay, really close and really close. We try observing the pattern. So from the left side, really close to 1, really close. Yeah, towards the left of the 1, but really close to 1, just like this black color line. Can you see that?
Yes.
Okay, can you see the function is still 3x plus 1, 3 times x plus 1?
Yes.
And can you see towards the right also the function is still is 3 times x plus 1?
Yes.
Okay, so function is not changing. Function is not
Okay.
changing towards the left of 1, towards the right of 1. The function is not changing. Why? You understand Hindi as well?
Yes, I do.
ओके, तो जब भी हम ये चेक करते हैं कि वन के लेफ्ट में और वन के राइट में क्या हमारा फंक्शन चेंज हो रहा है, अगर हमारा फंक्शन चेंज हो रहा है तो हमें लेफ्ट हैंड लिमिट और राइट हैंड लिमिट स्पेसिफिकली निकालना होता है। और अगर हमारा फंक्शन ही नहीं चेंज हो रहा है तो डायरेक्टली हम वन पुट कर देंगे, जो भी हमारा फंक्शन है लेफ्ट और राइट दोनों में अगर सेम फंक्शन है तो एक ही बार हम वही फंक्शन लेके, जैसे अब तक हम पिछले क्वेश्चंस को डील कर रहे थे, एफ ऑफ एक्स दिया हुआ रहता था और हमें x इज अप्रोचिंग 5, x इज अप्रोचिंग 6, x इज अप्रोचिंग 1 निकालना होता था। हर बार हम क्या करते थे, बिना कुछ सोचे फंक्शन जो भी हमें दिया हुआ होता था वहां x की वैल्यू हम पुट कर देते थे। अगर हमें फाइनल आंसर प्रॉपरली मिल जाता था तो वही हमारा लिमिट होता था। अगर हमारा फाइनल आंसर नहीं निकल पाता था, 0/0 आता था, तो फिर हम सोचते थे अब क्या, क्या कोई रूल यूज कर ले या फिर कोई सिंप्लीफिकेशन कर ले ताकि ये 0/0 सिचुएशन को हम अवॉइड कर सके। यहाँ जब हम x टेंस टू 1 हमें f ऑफ x निकालना है, लिमिट x इज अप्रोचिंग टुवर्ड्स 1, f ऑफ x जब हमें निकालना है तो हमने ध्यान से दिए हुए फंक्शन को नंबर लाइन पे रिप्रेजेंट किया। और यहाँ हमें रियलाइज हुआ कि 1 के लेफ्ट और 1 के राइट में फंक्शन तो हमारा चेंज ही नहीं हो रहा है। अब ये बात तुम्हें याद रखना होगा कि जब हम 1 के लेफ्ट हैंड लिमिट और 1 के राइट हैंड लिमिट की बात करते हैं तो 1 के बहुत दूर हम नहीं चले जाते, बहुत क्लोज और बहुत क्लोज रहते हैं 1 के।
That's why
यहाँ
we
तक
aren't taking 2x plus 3, right?
या व्हाट?
इसलिए हम लोग 2x plus 3 नहीं ले रहे ना।
इसलिए हम 2x+3 ले ही नहीं रहे, क्योंकि हम 1 के बहुत क्लोज ऑब्जर्व कर रहे हैं कि पैटर्न क्या है। इसलिए हम इस फंक्शन को तो लेंगे ही नहीं। क्यों? क्योंकि ये तो 0 से छोटे नंबर की बात हो रही है और हम तो 1 के बहुत क्लोज देख रहे हैं। जैसे जैसे
जी।
0.9,
जी।
0.99, 0.9999 ऐसे नंबर्स के पैटर्न को हम ऑब्जर्व करने की कोशिश कर रहे हैं। आ रहा है समझ में?
यस।
ओके, इसलिए हम उतना दूर तो जाएंगे ही नहीं, हमारा फंक्शन चेंज ही नहीं हो रहा है। हमारा लिमिट क्या निकल के आएगा? ऐसे ऐसे सिचुएशन में तो हम डायरेक्टली भी लिमिट फाइंड कर सकते हैं। कैसे? डायरेक्टली हम एक्स के प्लेस पे ओके हम ऐसे लिख सकते हैं, लेफ्ट हैंड लिमिट राइट हैंड लिमिट या तो हम लिख ले, कोई बात नहीं। ओके वी कैन राइट दैट लिमिट एक्स टेंस टू 1 माइनस, हम लिख सकते हैं एफ ऑफ एक्स। ओके लिमिट एक्स टेंस टू 1 प्लस एफ ऑफ एक्स, ऐसे या तो हम लिख ले, या फिर डायरेक्टली लिमिट एक्स टेंस टू 1 एफ ऑफ एक्स इज इक्वल्स टू लिमिट एक्स टेंस टू 1 3 टाइम्स एक्स प्लस
जी।
1। डायरेक्टली हम फाइंड कर सकते हैं। हमें लेफ्ट हैंड राइट हैंड, अगर हमारा कंसेप्ट क्लियर है, हमें लेफ्ट हैंड राइट हैंड लेना ही नहीं है, क्योंकि हमारा फंक्शन तो सेम ही है। ओके 3 टाइम्स 1 प्लस 1 दैट इज
That is equal to 3. Oh, 6. Sorry.
आंसर। क्लियर?
Yes.
ओके लेट्स कंटिन्यू विद द नेक्स्ट क्वेश्चन। मोस्टली हमारे चैप्टर में यहाँ पीस वाइज डिफाइन फंक्शन ही हमें दिए हुए होंगे, और हर बार हम पीस वाइज डिफाइन फंक्शन की ही लिमिट को फाइंड कर रहे होंगे। ओके लेट्स डू few piecewise defined function first.
Okay.
So find the limit x tends to 1 f of x, where again a piecewise defined function we are having.
Yes.
So here we can see we have to find limit x tends to 1 f of x. Now we can see towards the left of 1 and towards the right of 1 the function is getting changed. Okay here the function is x square minus 1 towards the left of 1. Okay x is smaller or equals to 1, this is the function. X bigger than 1, the function is minus x square minus 1. That means here we need to find the left hand limit and the right hand limit. Why? Because the function is getting changed.
Yes.
Making sense? Even though just
Yes.
there is a variation of sign, okay here minus sign, there not minus sign, still the function is getting changed, and carefully we have to find the left hand limit and the right hand limit. So we'll be finding limit x is approaching 1 from the left side, f of x is equals to limit x is approaching 1 from the left side, this minus is representing from the left side. Okay f of x will be this one, x square minus 1. Just put the value 1, just 1. Okay not minus 1, this minus is representing left side. Okay
Yes.
so just 1, so 1 square minus 1 is 0. Is 0 allowed? Yeah, 0 can be the answer. 0 by 0 is not allowed. Making sense?
Yes.
Okay limit x tends to 1 from the right side. Okay the function is minus x square minus 1, this one. Okay so we'll just drop
Okay.
1 at the place of x. Okay so we'll be
Yes.
having minus of 1 square
1 squared, which is equal
minus
to
1
1.
is equals to, please tell me what are we going to get?
1.
Do the calculation carefully, Miraj. Negative of 1 square minus 1, that means negative of just 1. 1 square will be just 1. Ayana.
Yes.
Okay
Okay.
minus
So minus 1 times 1. So it will be equal to minus 1.
1. This is not times, this is subtraction. Can you see?
Yes. Okay. Okay. Hmm.
1 square will be 1. Negative outside, fine. Minus 1. Can I say it will be minus 2?
Yes.
Getting it?
Yes.
Okay, clearly we can see the left hand limit and the right hand limit is not same. So we will declare that
Yes.
it is not possible to find the limit. Why? Because left hand limit and right hand limit is not same. From both sides, the answer should be same, then only we can declare the final answer. Okay, limit
Yes.
doesn't exist.
Yes.
Any confusion, Miraj?
No.
Now I am going to take
Can I
modulus. Yeah, do you want to write
can
it?
I note it down? Yes.
Yeah, yeah, sure. This one or the previous one as well?
Only this one. Done.
Let's move. Now I'm going to take modulus function. So we are having evaluate limit x tends to 0 f of x, where f of x is equals to a piecewise defined function. We are having mod x by x and here 0. We have to redefine this function. Okay, whatever limit we have to find, we will find it. But first we have to redefine this function. What does that mean? That means that we need to see here mod x is there. Okay, and have you learned, Miraj, in previous class that if we are having f of x is equals to mod x, okay, actually this modulus is like a machine. Okay, inside this machine, if we will drop a negative number, automatically the answer will be positive. If we will drop a positive
Yes.
number, the answer will be positive. Okay, so hence
Yes.
there was a function defined in the previous class. That modulus function is defined this way. If f of x is equals to mod x, we can say that it is defined as, we'll be having minus x when x is smaller than 0, and when x is bigger than or equals to 0, it is just x. What does that mean? That means that inside this machine, if we will drop a number which is smaller than 0, smaller than 0, okay, that means maybe minus 1. So what this machine will do, this will put one more negative sign like this along with our number and will make it
Okay.
positive, right?
Yes.
The programming of this machine is done like this. This two line works like a machine. Okay, that if it will sense a negative number, quickly it will give one
Yes.
more negative sign. If it will sense a
Yes.
positive number, it will be sitting idle, will not be doing
Yes.
anything.
Yes.
Okay, so that's how we define the function. See this curly bracket, how I have defined the function. When x is smaller than 0, then quickly it will put one more negative number by itself. Okay, this is the
Yes.
hidden process which we can see in the curly bracket, hidden process. Actually, outside final result always will be negative. When you will see the final result, always it will be positive. Okay, but this curly bracket is showing you the negative, the hidden process. Let me show you why it is like this. Mod of x we are having, if f of x is equals to mod of x we are having. Okay, we define it like this, that when we are taking a negative number that is smaller than 0, okay, quickly it put one more negative sign in along with our x. Getting it?
Yes.
And if we take a number which is bigger than or maybe equals to 0, it doesn't do anything, it just copy paste the same number. Getting it?
Okay. Yes.
So if you understand this modulus function really well, then only we can solve this question. Let's focus.
Yes.
So we need to, as I was telling you, that we need to redefine this function. Okay, otherwise we won't be able to understand that what is the left of the zero, what function we are having, what function towards the right of the zero. We need to write it again. We will be saying that our f of x can be written as, when x is smaller than 0, then this mod x will be one more negative sign, it will just drop in front of our
Yes.
x, and by x will remain as it is. And when x is bigger than 0, then it will not do anything with our x, it will just write it, just give the same x by x. Getting it?
Yes. Yes.
And when x equals to 0, we don't have to think about that, that was already given. Is it clear, Miraj?
Yes.
Okay, we are redefining the function. Now we can write one more time the same thing, so that we can write it as this one as a -1, this one as a just one. Getting it?
Yes.
I'm writing here only. Okay, that this minus x by x is nothing but just -1, and this is nothing but just 1. Okay, let's move. So we have to find what is happening when x is approaching limit. We have to find when x tends to 0. So towards the left of the 0, towards the right of the 0, this is how we understand. Towards the left of the 0, the function was minus x by x, which resulted to -1, right?
Yes.
And towards the right of the 0, the function was f of x is equals to
Yes.
x by x, that is
Yes.
just 1. Okay,
1.
now let's find the left hand limit and the right hand limit of the 0. Here f of x is just -1, can we write?
Yes.
And we don't have anywhere to put the x value as a 0, so this is the answer. Yes or no?
Yes.
Okay, if you want you can write this step, but we don't have anywhere to put this 0. Okay, so the answer will be same. If we are finding the right hand limit,
We can substitute it and minus x upon x, right?
yeah, but that will be just -1, right? Don't put 0 by
Yes.
0. Okay, that way it will not be
Yeah.
defined. Better to cancel it. Why? Because numerator and denominator has the same thing.
Yes. Okay.
Okay, and here
Yes.
again you can drop x by x, but don't try substituting 0, because 0, okay, that is not allowed. Again we will start thinking something, that what to do as a simplification. Already the simplification is possible, can we see that?
Yes.
Okay, so better we'll write 1 is the answer. Left hand limit and right hand limit is not same, hence limit doesn't exist. Getting it?
Yes.
Now just see the complete question and tell me, is it making sense? The complete solution, that how we were having modulus somewhere, and how patiently, okay, calmly we have just redefined it by our proper understanding that modulus works like a machine. How the elevator and everything, everywhere around us we are having machine. Okay, it will sense that there
Yes.
is a human and will open the door. If you are going and it is about to close, it will open the door, right? Because it will sense that
Yes.
something is there in between, right?
Yes.
Similarly, hence this function is behaving. Okay, if it is sensing a negative number, already it is quickly just throwing one more negative sign and making it
Yes.
positive.
Yes.
Okay, so yeah, this is the question, Miraj. If the
Yes.
question and the next step is clear, then you can note it down.
Okay.
And if anywhere any confusion, please let me know.
So,
Are you done, Miraj?
just 1 minute. That,
Okay, let's move.
so,
Okay, the next part you need. This is the next part, right?
yeah.
Yeah, do it.
Are we going to do the next question now?
Yeah, what you say?
Are we going to do the next question?
Okay, the next lesson, that is limits and
The
continuity.
next question.
Okay,
Uh,
next question we can do, right?
Yes, yes,
Yeah. Okay, let's do few more questions, then we can proceed. Yeah. So the next question is, suppose we have to find the limit x tends to 5, f of x, where again our f of x contains modulus function, that is mod of x minus 5. Okay, let's see
yes,
how to find over here. Again, do we have to redefine this function, or we can take it as it is? Yes, we can redefine this function. We can say that f of x can be written as when x is smaller than 0. That means any negative number, if we will take even minus 0.5, minus 0.9, minus 1, or minus 1.5, any negative number we will take, automatically this machine will sense and will throw a negative sign in front of our number, right?
yes,
Okay, and in case we are taking x as a positive number greater than or maybe equal to 0, it will just give as the same x. Okay, it will not do anything. So actually the function was mod of x minus 5. So I must write minus x minus 5 like this. Getting it, Miraj? X minus 5 like this. Getting it?
yes, yes,
Okay. So these are the two way our function is defined, and we have to find x tends to 5. Somewhere 5 is there. Now towards the left of the 0, right of the 0, function is getting changed. Okay, towards the left of the 0, the function is minus x minus 5. And towards the right of the 0, the function is x minus 5. And we are thinking, what about towards the left of the 5 and right of the 5? And as I was telling you, when we are checking towards the left of 5 and right of 5, we are thinking very closer, very closer, very closer. We don't go that far. Making sense?
yes,
That means the function is just this one. Are you getting it?
yes,
Okay, so for this limit we don't have to take, okay, the left hand limit, right hand limit. Our function is not getting changed. Directly we can find the limit. How? We can take limit x tends to 5. Okay, f of x, at the place of that we can write x minus 5. Then we can put the x value, that is 5 minus 5, that is 0. Making sense?
yes,
Is it clear, Miraj?
yes.
Okay, please do it.
Okay. Done.
Okay. Now we are going to start with, now you will understand everything, whatever is here.
So,
For checking the continuity of a function, we have to check the limit at that point, whatever point is mentioned, and we also have to find the function's value at that particular point. For initially, when we will be solving question, it will feel, you will feel that it is very obvious every time. Yes, we will be getting the same answer. For example, check the continuity of the function f of x is equals to 2x plus 3 at x equals to 1. We are supposed to check at x equals to 1, the function is continuous or not. Okay, the graph is smooth or not and all. Okay, we don't have to plot the graph. We don't have to think in the graphical manner. Yeah, the understanding is required, but actually you need to check limit x tends to 1, f of x, what is that, and what is that value, and you also need to check what is f of 1. If this one and this one is matching, that means the function is continuous. Okay, listen to me carefully, Miraj. You have to check the left hand limit of 1, you have to check the right hand limit of 1, and you have to
yes.
check the function's value at 1. If all these three is matching, that means the function is continuous.
Okay. All of
Okay,
them should be equal.
yeah, if all these three are not equal, then the function is not continuous at 1. Here I'm not talking about left hand limit and right hand limit. Why? Because the function is not piecewise defined function. Making sense?
Yes.
Okay, so for this type of question, I will be telling you limit x tends to 1. But the moment I'll see piecewise defined function, I'll start saying left hand limit, right hand limit has to be same, and f of 1 also must give the same answer. Okay, so
Yes.
let's start with the solution. If continuity,
Oh,
we are having one and only one concept. You should understand the graphical aspect also, that wherever x is 1, okay, from the left of 1, y value should, okay, try approaching the same number. From the right of 1, y approaching same number. And at 1 also, y is approaching same number. When we are talking about left of the 1 and right of the 1, we are talking about very close points, very close, very close. Making sense?
yes.
Okay, and at y also, if all these y is same number, that means the function is continuous at x equals to 1. If all these are not giving the same value, that means the function is not continuous at x equals to 1. Making sense?
Yes.
So let's find the limit x tends to 1. This is the question. And we are finding the limit. Who said? By ourselves. With proper understanding, because we have to check the continuity, we will be checking the limit x tends to 1, f of x will be limit x tends to 1. Here we don't have to do anything, just we have to drop the x value. But this is not the only way to find the limit. Sometime we will face difficulty, that time we will be thinking what to do. But here we can find easily, right?
Yes.
This is the limit. And what about f of 1? F of x is 2x plus 3. So f of 1 will be 2 into 1 plus 3, right, Miraj? That is 2
Yes.
plus 3. That is 5.
Yes.
So we can see the
Yes.
limit and the function's value at 1 is same. Hence the function is continuous at x equals to 1. Getting it?
Yes.
Okay. We are done with example number 1. Okay. You can check after the class the example number 1. You will understand. Okay, Miraj?
Okay.
Now we'll be doing few question from the exercise. First, we'll be doing level 1 question. Then I'll be moving to level 2 question.
Okay.
Can you see the first question over here, Miraj? Is it
Yes,
readable?
yes, it is.
Okay, prove that the function f of x is equals to 5x minus 3 is continuous at x equals to 0. At x equals to minus 3 also it is continuous. We have to prove it. And at x equals to 5 also it is continuous. We have to prove it. Right?
Yes,
So at first we are checking at x equals to 0, it is continuous or not. We will be finding limit x tends to 0 f of x. We are not talking about left hand limit and right hand limit. Why? Because the function is not piecewise defined function. Making sense?
yes.
Limit x tends to 0, 5x plus 3. Please tell me 5x minus 3. My bad. Tell me the answer.
Uh,
Yeah,
7
the limit value. The limit value, Miraj. Here, here.
will be equal to 7.
7. If you will put x as a 0, are you going to get 7?
No, no, minus 3.
Minus 3. Is there any confusion?
No,
This is how you find the limit, right?
yes,
For the basic question, this is how you find the limit. Okay? When it is 0 by 0, then you do something else, right?
yes,
Okay? Now 5x minus 3 will be finding f of 0. Why? Because at 0 we are checking. At 0 we are checking it is continuous or not. So we have taken the limit x tends to 0 by ourselves and we are finding f of 0. Are you getting it, Miraj?
yes.
Okay. F of 0, can you tell me what are we going to have?
Minus 3 again.
Yeah,
Minus 3.
again minus 3. So we can say since the limit that when x is approaching 0, the limit left and right hand both, okay, is same as the function's value at 0. Therefore f of x is continuous at x equals to 0. Making sense, Miraj?
Yes,
Can you do the same thing for x equals to minus 3? When x equals to minus 3, can you do it by yourself? X equals to minus 3,
yes.
do it.
Okay. Minus 18.
Uh, all are same, the limit and the function's value at minus 3.
Yes,
Okay, so same way you can write the function is continuous at x equals to minus 3. Are you understanding what we are doing, Miraj, and why we are doing it?
yes.
Okay. Similarly, the next question we are having. After today's class, you will be solving the first question. Okay. One part is left. That what about x equals to 5? So you will be solving it. Examining the continuity of f of x at x equals to 3. You will be doing question number 2. Okay. And let me check what else you can do. Just do this two question. Okay, Miraj?
I'll do them as homework.
Yeah, what?
Should I do them as homework?
uh, this one by yourself you should do. Homework I'll send you another one. Okay, this one
Okay,
you should do just for practicing, and in the next class let me know that you were able to do it or not.
okay.
Okay, and homework I'll send you another homework. Any confusion, Miraj, so far?
I'll just look at the sum again and check if I have any doubt.
Yeah, sure. So do you want to ask anything?
Can you show the question once again?
Can I show the
Question once again.
question one? This one?
Yes,
Okay.
yes, the
Yeah,
one
sure.
we did. Okay,
This one, right?
yes.
Shall I explain it or just you wanted to see the solution?
I'm checking if I have any doubt.
Yeah, check it. जब भी हमसे
If
कंटिन्यूटी पूछा जाता है, जब भी
yes,
हमसे कंटिन्यूटी पूछा जाता है मिराज, किसी एक पर्टिकुलर पॉइंट पे कि चेक करके बताओ एक्स इक्वल्स टू जीरो पे हमारा जो फंक्शन है वो कंटिन्यूअस है या नहीं है, तो हमें क्या फाइंड करना होता है? एक्स जब जीरो को अप्रोच कर रहा है तो हमारा एफ ऑफ एक्स का वैल्यू क्या निकल के आ रहा है, हमें ये चेक करना होता है। मतलब लेफ्ट हैंड लिमिट राइट हैंड लिमिट ये दोनों हमारा सेम आना ही चाहिए। जब हम कंटिन्यूटी चेक कर रहे हैं तो लेफ्ट हैंड लिमिट राइट हैंड लिमिट मतलब लिमिट एग्जिस्ट करना ही चाहिए। ओके, दोनों सेम आना ही चाहिए। और हमारा फंक्शन का वैल्यू जीरो पे वो भी सेम आना चाहिए, जो लिमिट की वैल्यू आई है वो फंक्शन की वैल्यू जीरो पे आनी ही चाहिए। तो अगर हम
okay,
जीरो पे चेक करें हमारा फंक्शन कंटिन्यूअस है या नहीं है, तो ध्यान से देखो हमने सबसे पहले क्या फाइंड करा है, हमने लिमिट फाइंड किया है। हमें चेक करना होता है कि हमारा लिमिट का आंसर और एफ ऑफ जीरो का आंसर क्या ये दोनों सेम है। अगर ये दोनों सेम है तो हाँ हमारा फंक्शन जीरो पे कंटिन्यूअस है। यहाँ हम लेफ्ट हैंड लिमिट और राइट हैंड लिमिट बार बार मैं नहीं बोल रही हूँ। क्यों? क्योंकि अभी अभी हमने लिमिट डिस्कस करा है, वहां पे ऐसे फंक्शंस के लेफ्ट हैंड लिमिट राइट हैंड लिमिट दोनों सेम ही होते हैं, क्योंकि फंक्शन हमारे चेंज नहीं हो रहे। आ रहा है समझ में?
yes, जी,
ओके, तो इसलिए डायरेक्टली मैंने लिमिट निकाला है और डायरेक्टली एफ ऑफ जीरो निकाला है। जब जरूरत पड़ेगी तो हम जीरो के लेफ्ट में लिमिट जीरो के राइट में लिमिट और एफ ऑफ जीरो की वैल्यू तीनों को मैच कराएंगे। आ रहा है समझ में?
okay.
अगर तीनों
तो
मैच करेंगे तो हम बताएंगे हाँ कंटिन्यूअस है। अगर तीनों नहीं मैच कर रहे देन हम बोलेंगे कंटिन्यूअस नहीं है। आ रहा है समझ में?
जी, इसमें तीनों मैच कर रहे हैं हम लोग, नहीं ना?
हाँ, यहाँ तीनों ही मैच कर रहे हैं। आई मीन लेफ्ट हैंड लिमिट राइट हैंड लिमिट मैंने एक बारी में ही निकाल दिया है और एफ ऑफ जीरो निकाला है। दोनों के वैल्यू यहाँ भी -3 और यहाँ भी -3 मैच कर रहे हैं या नहीं मिराज?
जी,
ओके, मैच कर रहे हैं। इसका मतलब कि हमारा फंक्शन कंटिन्यूअस है जीरो पे। आ रहा है समझ में?
जी,
ऐसे ही अगर हमसे बोला जाए कि सेम फंक्शन को चेक करके बताओ थ्री पे कंटिन्यूअस है या नहीं, या फिर -3 पे कंटिन्यूअस है या नहीं, या फिर 5 पे कंटिन्यूअस है या नहीं, तो हम लिमिट एक्स टेंस टू -3 निकालते हैं और एफ ऑफ -3 निकालते हैं। जो लिमिट का आंसर आया है एफ ऑफ -3 का आंसर भी सेम आना ही चाहिए। अगर दोनों सेम आ रहे तो हाँ एक्स इक्वल्स टू -3 पे हमारा फंक्शन कंटिन्यूअस है। अगर लिमिट का आंसर कुछ आया और एफ ऑफ -3 का आंसर कुछ और आ गया तो हमारा फंक्शन कंटिन्यूअस नहीं है -3 पे। आ रहा है समझ में?
जी,
ओके, सिमिलरली हमें सेम फंक्शन के लिए x इक्वल्स टू 5 पे भी चेक करना है। तो हम लिमिट x टेंस टू 5 निकालेंगे एफ ऑफ एक्स, और हम एफ ऑफ 5 निकालेंगे, और दोनों का आंसर हम देखेंगे दोनों के लिए सेम रिजल्ट आ रहा है या नहीं। अगर सेम रिजल्ट आ रहा है तो x इक्वल्स टू 5 पे हमारा फंक्शन कंटिन्यूअस है। अगर सेम रिजल्ट नहीं आ रहा है तो हमारा फंक्शन x इक्वल्स टू 5 पे कंटिन्यूअस नहीं है। क्लियर?
जी, जी।
ओके,
हम लोग वैसे
सेकेंड।
इसमें यहाँ पर सिर्फ लेफ्ट हैंड लिमिट और राइट हैंड लिमिट चेक कर रहे हैं ना, हम लोग को कोई तीसरी चीज भी चेक करनी पड़ती है ना, ये बताने के लिए कि कंटिन्यूअस है कि नहीं
या हमें लेफ्ट हैंड
फंक्शन।
लिमिट और राइट हैंड लिमिट दोनों चेक करनी होती है, लेकिन लेफ्ट हैंड लिमिट राइट हैंड लिमिट की बात हम तब करते हैं जब हमारे पीस वाइज डिफाइंड फंक्शन है। ओके, यहाँ तो हमारे पीस वाइज डिफाइंड फंक्शन नहीं है, राइट?
यस।
ओके, सेम फंक्शन है, आई मीन टुवर्ड्स द, अगर हम जीरो के लेफ्ट में देखें तो हमारा फंक्शन 5x-3, अगर हम जीरो के राइट में देखें तो हमारा फंक्शन 5x-3, हमारा फंक्शन चेंज नहीं हो रहा है, एक बारी में ही हम लिमिट निकाल सकते हैं, राइट?
यस।
एनी कंफ्यूजन?
नो।
Okay, so you will be able to do the first one and the second one. Please do it and let me know if you are having any confusion from here, Miraj. Okay, I'll also be sending homework to you. Okay, please do that and let me know your confusion. Any more?
शुड आई डू दिस सम नाउ इटसेल्फ?
Yeah, you can do. Okay, now another class is going to start. So if you'll take a screenshot or maybe if you will quickly note it down, it will be helpful. I am also having another class.
ओके, थैंक यू।
Okay. Yeah, you will be able to do, don't worry. And in the next class, I'll be starting from here itself. Okay.
ओके।
Yeah. So yes, Miraj, I'm keeping this much